Good day, everyone. All right, so in this video I want to discuss question 5C from the 2022-2023 SP025 paper. Okay, so just a quick look on the diagram, right, before reading the question. We do not have an inductor, so this is just an RC circuit, so that's nice. I just want to make a note here that my XL is equals to 0. That's for sure. Now we read the question. Figure 5 shows a 1.6 milliamp current, so that's our current, flows through a 20 kilo ohm resistor, that's our second information, and a 0.45 microfarad capacitor, third information. And then fourth information comes much later, capacitor which are connected in series with a 50 hertz AC supply. Okay, so here we have our we have our I, we have our R, we have our C, and we have our frequency. Okay, the first question goes, calculate the capacitive reactance. Now, by definition, your capacitive reactance is simply the inverse of 2 pi Fc. In comparison, just to remind you, just for us to remind ourselves, XL, which is the inductive reactance, there's no such inverse. You just have 2 pi FL. Okay? Okay, so I can immediately just substitute the values. I can have XC equals to 1 over 2 pi. My F is 50. My C is 0.45 times 10 power of, well, we see that it's micro, so it's going to be -6. Okay, so it's going to be -6. Now, take a minute and calculate that into your calculator, or at least input that into your calculator, and what you'll find, it is going to be 7073 ohm. So that's about 7 kilo ohm. That's about 7 kilo ohms. Okay. All right. So we have solved, or at least we have answered the first part of the question. The second part of the question asked us to calculate the RMS voltage of the AC supply. Now, this I here, the current here that they have given, they did not mention, or they did not say that it is a peak current. So our assumption is that this is going to be our IRMS. Now for a circuit like this, we will have our IRMS is going to be equal to VRMS over Z. So what that means is that we have to calculate what our Z may be. Okay. So if I just rearrange that, I will have VRMS times IRMS. VRMS equals to IRMS times Z. Okay, so our IRMS is nice. We know the exact value, but our Z, we have to express our Z in terms of XC, our capacitive reactance, and our R. And that will look something like this. So it should be R square plus XC square rooted. Okay, so then we're left with VRMS is equals to, we can substitute the values, which is 1.6 times 10 power of -3. Then we have our R square. Our R square here, our R is 20k. So it's going to be 20 times 10 power of 10 power of 3 squared plus XC, which is 7073 squared, and then the whole thing to be square rooted. Okay, so again, take a minute to input this into your calculator, and what you'll find is that your VRMS is going to be approximately 33.9 volts, and that is your RMS voltage of the AC supply. In some other questions, they might use the RMS voltage of the whole circuit, you know, but that also refers to this AC supply. Okay, so that means if they say either AC supply or the whole circuit, you use Z, which is the impedance of the whole circuit. Okay, thank you.